No amount of experimentation can ever prove me right. A single experiment can actually prove me wrong. Those are the words of Albert Einstein. Now, if we sort of fast forward probably about 100 plus years from when he said that, we're in the world of algorithms now. What is the role of experiments in the evaluation of algorithms? What are the advantages? And what are the potential limitations of using experiments as a means of performance evaluation of algorithms? So let's start by articulating a potentially simple problem. The problem statement is that we want to sort a list of numbers. You have an input, which is a list of numbers which are unsorted, and you're expecting an output, which is the same list of numbers, but now they are sorted. Now, there are actually plenty of sort of candidate algorithms which can actually provide a solution to this particular problem. Now, algorithms can actually work in very, very different ways, and they can have different trade-offs in terms of performance and memory usage. So let's assume we have two candidate solutions for our problem, algorithm A and algorithm B. And both algorithm A and algorithm B actually provide the correct solution. So assuming we actually have algorithms which work correctly and do the job, we actually need some performance metrics to work out which algorithm is better. Is algorithm A better, or is algorithm B actually better? Now, a very natural metric is to consider how long it takes to do the job, i.e. the running time. Clearly, the faster it does the job, the better the algorithm. One way to start analyzing and understanding execution time is to just simply run some experiments on the computer, right? So what we would do is a very, very simple approach. Take an algorithm, identify a set of test inputs, execute the algorithm, and actually then record the running time or the execution time for each specific input. What is our interest? Our interest is actually in the relationship between the execution time and the size of the input. So let's get back to sorting algorithms A and B. And essentially what we do is we run a bunch of experiments with different input sizes. What do we get? What we are really interested in is the relationship between the running time and the size of the input. So the key point is that both algorithms actually solve the problem, but they seem to have different relationships to the input size. So the question for you is, which algorithm is potentially better and why? So based on what we've actually seen so far, what are the potential advantages of running experiments and what are some possible limitations? So if you look at the advantages, it's a great way to start. Very quickly you can actually do something, and very quickly you can actually develop some intuition about the algorithm. It's also great for small scale systems. You can just quickly do something, get it off the ground. Now, if you're looking at the limitations, then any insights that we get, those are only with respect to the specific test inputs. And any results that we get, again, are dependent on the very specific implementation environment. So with this very brief introduction into the use of experiments to evaluate algorithms, what do we actually need? What we want is an analysis and an understanding of algorithms which A, does not depend on the input sizes. In fact, the analysis of the algorithm is irrespective of the input sizes. And the other thing that we actually need is an understanding of the algorithm which is independent of the implementation environment, i.e. independent of the hardware, the software, or the actual programming language that you use to implement the algorithm. So essentially what we need is a theoretical framework that can actually complement experiments, which will help us analyze algorithms, things like their runtime, without actually running experiments. And a framework which can actually help us design better algorithms. So in an ideal world, what do we really need? We probably need a judicious combination of theory and experiments which can help us design good algorithms and can actually guide implementation decisions.